Hi, this is Sean Bin Long presenting the third lab of Physics 2211. In this lab, the purpose was to utilize the computer model to find the mass of the black hole as well as the initial velocity of the ship that it needs to take off from in order to not crash. And some result preview is that the mass of the black hole ended up being around 1.3 times 10 to the 34 kilograms, and the initial velocity of the ship ended up being negative 9 times 10 to the 6 in the x direction and 9 times 10 to the 6 in the y direction. And some key concepts and assumptions we used in this lab was the universal gravitational force equation, as well as Newton's second law. And the key assumption that we're making is that the magnitude of the force of gravity or the gravitational force is equal to the magnitude of the net force. So we can set the equation equal and find the mass of the black hole. Now, this is the computer modeling where the system is the black hole in the center, and the surrounding is a star that's orbiting. Now, for the initial condition of this part is that we're using the gravitational constant, the stars, the mass of the star that's orbiting, and delta t, which is in the number of seconds in one day. And the loop that we used in this part of the lab is we set the magnitude of the universal gravitational force equation equal to the magnitude of dp over dt, as well as the parallel and perpendicular component of the net force to find the mass of the black hole, resulting in a mass of around 1.3 times 10 to the 34 power kilograms. Now, in the second part, when we find the initial velocity of the ship, where the system is the ship, and the surrounding is the star and the black hole. Black hole's in the middle, and the star is the cyan star that's orbiting. As you can see, the ship is not crashing into anyone. And the initial condition that we used in this part was the same as the first part plus the mass of the black hole from the first part, the planet speed, planet's velocity, as well as we guessed and checked to find the ship speed in both x and the y direction. Now the loop to find this part was that we found r and r hats, the forces from planet and black hole to ship, and the force act from ship and black hole that's acting on the planet. And this resulted in the initial velocity of the ship being negative 9 times 10 to the 6 in the x direction and 9 times 10 to the 6 in the y direction. Now, although no real life model was observed, the similarity of the computer model and the theories on physics is still present. The ship needed a very large velocity to escape the pull from the black hole, and the predicted mass of the black hole was very large as predicted by the laws of physics. Now, some possible sources of error: the mass of the black hole was constantly changing, so as the program ran longer, we had a more accurate result. And also for the velocity of the ship, since we achieved that by a guess and check method, the actual velocity could differ a little. Now, some discussion conclusion: what is and what does it mean? How the net force and its parallel and perpendicular component are different from the rate of change of momentum and its parallel and perpendicular components. As seen in the equation and observed in the model, they're the same. There's no difference. They're proportional to each other. Now, the what if: what initial velocity would the ship needs to be in order to enter some kind of orbit around the black hole? The velocity of the ship will be very similar to the velocity of the planet, as the planet is already in a certain orbit.